Hello students, hope you all are well and enjoying all the videos that I am posting regularly on my channel, and see that you use it for your studies. As I promised you, again I am back over here with another video on a new concept, that is your chapter 1 of 10th standard, chemical reaction and equation. Students, this particular chapter I'll be posting it in 4 to 5 parts of it. So see that you keep it in continuation with all the 5 videos and study this particular chapter well. Okay, let us start with the video. So students, today we will be starting with chapter 1 of standard 10, that is chemical reaction and equation. Students, to understand this particular chapter, first we will have to understand what do you mean by chemical reaction. Correct, students? So the process in which new substance with new properties are formed from one or more substance is called chemical reaction. What does this mean, students? When you are mixing two substances, say for example salt and sugar, after that if you just separate out them, you will be able to separate out them by looking at the color, or maybe by putting the crystal on your tongue. If it tastes sweet, then you say it is sugar crystal, and if it is tasting salty, you say it is salt crystal. Correct? But so this is not a chemical reaction, it is called mixture. Here the substances, that is, we have made the two substances together, mixed together, but they have not reacted with each other. When they react with each other, they are going to lose their original property and gain some new property. But instead of that, if you heat sugar and salt, after that it is just going to melt and become one. When you get this particular liquid, you try to taste it. It's neither going to taste you sweet nor salty, because now sugar and salt crystal have chemically reacted with each other. In chemical reaction, what happens is the bond between the atoms, the particles, they break and again rearrange, and some new molecule, particles are formed, and thus they will be having some different property. So when two or more substances are reacting together and some new substances form, then only we say it is chemical reaction, otherwise we can't say. Clear, students? So here I have just written in the mathematical form, S1 plus S2 is giving you S3, where S1 and S2 are called reactant, and they are giving you another substance called S3. Okay, that is product. Few examples of chemical reactions are, say, rusting of iron, digestion of food, burning of magnesium ribbon, formation of curd. Formation of curd, if you just try to understand, curd is formed from milk. Milk is sweet in taste, while curd is sour in taste. So it has lost its original property. Clear? Now, what does the chemical reaction involve? What happens in the chemical reaction? How can you identify that the chemical reaction has taken place or no? So the first thing is, in a chemical reaction, the change in state is observed. The change in state is observed. It means when you eat something, the solid state will change into liquid, or liquid changes to gas, and vice versa, gas to liquid or liquid to solid. So the state of the reactant will always change. There is also change in the color. If you just see rusting of iron is generally grayish black in color, but when it gets rusted, it is becoming brown in color. So there is change in the color also. Change in temperature, this is very, very important, students, because during the chemical reaction, as I told you, there is the breaking of the bond and the rearrangement of these molecules back into some new molecule. So during this breaking of the bond, that is chemical bond, some energy may be liberated, or maybe for the formation the energy may be required. Okay, so there is going to be the change in temperature. The chemical reaction in which energy is required that is called endothermic reaction, while if energy is liberated during the reaction, then it is called exothermic reaction. Clear, students? Even during the chemical reaction, gas may be evolved. That is, say for example, if you say photosynthesis reaction, then in that oxygen gas is liberated. It is given out. So during a chemical reaction, even the gas evolution will be seen. So either of these four, it may be that all the four will be seen, or it may be out of the four any 2, 3 can also be seen in a chemical reaction. Clear, students? So let us go for the next concept. That is, how can we show the chemical reaction? Instead of using the explanation, that is words, how can we represent this chemical reaction? So for representing the chemical reaction, there are two ways. One is word equation. Word equation means we write it in words, what is reacting with what and what is formed. So here I have written the equation for the water formation, that is hydrogen is reacting with oxygen to give you water. So I have just written it in words to show the reaction. And the another method is by writing the chemical equation. By writing the chemical equation, I am going to use the molecular formula of the same. Hydrogen molecular formula is H2, oxygen molecular formula is O2, and water is H2O. Correct? So here I have just written the molecular formula of oxygen, and here is the molecular formula of water. And the arrow is always shown while writing a chemical equation. Arrow is always shown towards the product side. Okay, students? So what is chemical equation in short? Chemical equation can be represented by a chemical equation. It involves uses of symbol of elements or chemical formula of the reactant and product, which is going to also mention the physical state. Clear? Now, physical state, say for example over here, this is gases, so I write G over here. This is gaseous state, so I write G over here. And this is the water that is formed will be in the liquid state, then I write N over here. Correct? So the state of the substances, that is reactant and the product, are written in bracket this particular way. S will be, S represents solid, L represents liquid, G represents gaseous state, and there is another called AQ. AQ is says about aqueous solution. Aqueous meaning the substance is dissolved in water. The solution is made in water. Clear? And if there are any conditions which are necessary, then that has to be written over here on the arrow. That is, if electricity, if we see the reverse one, is the electrolysis of water, then I need to supply electric current. So I'll write electricity over here. Correct? So if any temperature is required or any heating, if heating is required, we always show triangle for that. So any condition, say catalyst is required, then the name of the catalyst is written over here. Pressure is required, then the amount of pressure, for what time period pressure is required, that is written over here. Clear, students? So whatever the conditions are required has to be written on this arrow. So let us go for the next. Students, according to the topics from your textbook, the next concept has to be the balancing chemical equation. But balancing chemical equation is a little bit larger topic, and I will be more happy to explain you how to balance it by the method that is given in the textbook, as well as some extra method, and make you solve 2-3 examples. So I'll be making a special video for explaining you how to balance the chemical equation. So we are leaving this particular part for this particular video. Let us go for the types of chemical reaction. The first one is combination reaction. The word itself, combination, combine, that is two substances combined together to form some new substance. So I have written a schematic equation over here. A plus B is giving you C. So A and B are reacting with each other to give you a compound or a substance. You can say it is C. So reaction in which two or more reactants combine to form a single product. So the example is burning of coal, where carbon is burning, meaning it is reacting with oxygen, that is oxidation. So the combustion of coal is carbon is reacting with coal is nothing but carbon, students, remember. So carbon is reacting with oxygen to give you carbon dioxide. You can see the state over here written gas, solid. Okay. Now here, as I just explained you, exothermic reaction where heat energy is released, and endothermic reaction where heat energy is required. So exothermic reaction is a reaction in which it is released along with the formation of product. For example, burning of magnesium ribbon. Magnesium, when it burns, it is going to give you MgO, that is magnesium oxide, and it gives you light energy. So in an exothermic reaction, it's not always necessary, students, that heat energy only will be liberated. The energy will be liberated in any other form also, that is light energy, as shown in this particular reaction. So the next reaction is decomposition reaction. You know the meaning of compose, students? We always use the word that is so and so music is composed by so and so person. So compose means making, correct? Decompose meaning opposite of compose, that is to break it. Okay, so decomposition reaction is also having the near about same meaning. In decomposition reaction, one particular bigger molecule, bigger particle is broken down into smaller substances. Okay, so example, if I give you here, if I write AB breaks into A and B. You can even use C for that, because when I write AB, you may understand it as that the constituent elements are separated, but it's not necessary that always whatever the constituent elements which are reacted to form AB, they will be getting separated. So C is completely different substance which is going to break into two smaller substances called A and B over here. So the reaction in which compound splits into two or more simple substances is called decomposition reaction. Clear? So there can be thermal decomposition where for breaking of the molecule heating is required. So example of thermal decomposition is CaCO3. Students, I told you about triangle. So you can see over here, when calcium carbonate is heated, it breaks into calcium oxide and carbon dioxide. See, now I think so it's very clear why I wrote C over here instead of AB. So CaCO3 is not breaking into Ca plus C plus O. According to AB gives A and A plus B. So I have written C gives A plus B. Okay. So it's not necessary that it is going to break up into its constituent element, but it will be forming some new particles. It can be more than two also, students. Not necessarily always two. Clear? And if there can be electrolytic decomposition. The example can be for water electrolysis, that is breaking of water molecule into hydrogen and oxygen by supplying electric current to the water. Clear, students? So let us go to the next reaction. Students, there can be also photolytic decomposition. Photolytic decomposition means where light energy is used for the decomposition. If you put AgCl, silver chloride, in sunlight, then it is going to break into solid silver and chlorine gas will be liberated. So here sunlight is used, and you can see the condition used is written on the arrow. Clear? Endothermic reaction, students, as I just told you, during the reaction heat energy is required. Okay. So endothermic reaction, chemical reaction in which energy is required in the form of heat, light or electricity to break the reactant. Now the next type of reaction is displacement reaction. Students, what is displacing? Displacing means we are going to remove some substance from a place, and in that particular place we are going to put something else, that is called displacement. So it's the same linguistic meaning over here, that is reaction in which more reactive element is going to displace a less reactive element from its salt. Obviously students, only a more reactive person can displace the less reactive. Okay, now say for example, if you are sitting on a place and watching TV or maybe picture or so, and if your small brother or sister comes and tell you, hey, just get up, I want to sit, then because you are elder, you may say come on, sit down, I can't get up over here, this is my place, I want to do and this and that. But instead of your small brother sister, if your grandpa or mommy daddy comes and they ask, beta, just get up from here, I want to sit, then you are going to get up. Clear? So more reactive substance only can displace the less reactive substance. So over here, this is the example where Fe, iron plus copper sulfate, which is in aqueous form, when they are made to react with each other, you get ferrous sulfate and copper. So here we can say that Fe, because it has removed Cu and taken its place, we can say that Fe is more reactive than copper. So the one which is less reactive will be always separated out. Clear? There can be even double displacement reaction where two substances will be displaced, that is the places will be just interchanged. Reaction in which new compounds are formed by mutual exchange of ions between two compounds. You can just see the example, sodium sulfate, when it reacts with barium chloride, sodium goes with chlorine and barium goes with sulfate, so you get sodium chloride and barium sulfate. So here the displacement of two, sodium has removed Ba and Ba has displaced sodium place. So over here it is the example of double displacement reaction. Moreover, you can see the downward arrow over here, that is the insoluble barium sulfate is formed. So when such insoluble substances are formed, we say it is precipitate formation. Precipitate can be written as small ppt, not the PowerPoint presentation capital PPT. Okay students? So the white precipitate of barium sulfate is formed, and thus this reaction is also known as precipitation reaction. Students, still 2 to 3 topics are still remaining from this chapter: oxidation, reduction, reaction, even the effects of the oxidation and reduction in our day-to-day life, and the balancing of the chemical reaction, that we'll be seeing in our next lecture. Okay, so still I'll be having 2 videos of the same chapter. Okay, so we'll meet for the next lecture. Till then, goodbye students.